So we have to calculate to 1 decimal place the length of DC. So DC is at this point. Therefore, what we're going to do is just to extract the figure that is adjacent to it. And if I extract that figure in this form, 90 degrees as that point A, point D, and point C. Here we have 5 centimeters, 3 centimeters. So point DC can be found by applying Pythagoras theorem. So you will say that DC squared is equals to DA squared plus AC squared. Therefore, DC squared is equals to AD, which is 3 squared, 9, plus 5 squared, 20. You find the sum of the two, so that D squared is equals to, if you add that, you're going to have 34. Therefore, remember our instruction is to find our answer into one place. So we are going to say that DC, it is the square root of 34. And if you press that, make sure that you have fixed your calculator into 1 decimal place, that is 5.8 centimeters. So we can proceed. You are told to find the size of angle ADC. And to find the angle ADC from this figure, you are going to look at the angle that they want. It is D, and on my figure I can see that angle D, it is somewhere there. Therefore, what we are going to say, because I have the opposite and the adjacent, we are using trigonometry rule here, where we have opposite and adjacent. And this one, it is only tan that applies the opposite and adjacent rule. So we are going to say that the tan of the angle theta is equals to opposite, which is 5, over adjacent, which is 3. Then the angle theta becomes the tan inverse of 5 over 3. So if we can work on that, we find that the answer of the angle, it is 59.0 degrees. Remember, the instruction was to leave your answer into 1 decimal place. And we continue by finding the next part of angle ACB. Now ACB, if I look at this figure, ACB, it is the angle here. So if I extract it out, think angle C here, AB, we have 8, 5, 11. So to find the angle, we are going to use, because we have 3 sides and we don't have any angle inside, what you apply, it is called the cosine rule, where you will say that A squared is equals to B squared plus C squared minus 2BC cos theta. Or you can make theta the subject and it becomes cos inverse of B squared plus C squared minus A squared over 2BC if I use theta as the subject of the formula. So if they want the angle C, the sides that are opposite to it becomes B and C, and the side that is opposite to it becomes point A. Therefore, theta is going to be cos inverse of B, which is 8 squared, plus 5 squared, minus 11 squared. Remember, we are adding the opposite sides here. The opposites you add, then we subtract with this side. All over 2 times the ones that I have added, 2 times 8 times 5. That is the easiest way if you don't want to apply more of cosine rule. So to work out on that, we have 8 squared plus 5 squared minus 11 squared divided by 2 times 8 times 5. Then we find the cos inverse. Therefore, our answer there should be 113.6 degrees. Remember what they want, all the answers must be into one decimal place. Then they want you to find now the area of the quadrilateral. And if I look at this quadrilateral, it has got point A and point B. These are two different figures. And on this one, since it's a right angle triangle, I can apply a half base times height. So to apply a half base times height for this, it will be a half times 3 times 5 for the first figure, plus we have the second figure here that we have just found the angle at this point to be 113.6. And we know very well that if I have a triangle that has got two sides and one angle, I can apply a half AB sine theta. Therefore here I'll say it is a half times 5 times 8 times sine 113.6. Then you can press on that one to get the total area, and remember your answer must be into what has been explained there as one decimal place. So